Just a little quick history with the BMD. I think it started out with the SCB tests were very prevalent right at the start. LSU and the University of Illinois both developed tests. And as they went through academia, they were very well received. But when it got out to actually into production and into the industry hands, found out there was a lot of issues with sample preparation, and there was an extra saws that needed to be done, cuts and notches, et cetera. So Dr. Fujisawa out at Texas A&M came up with the Ideal CT, which allows you to pretty much use a standard gyratory pill cut down anywhere between 62 and 95 millimeters in order to get the same parameters and have a good number for the crack resistance of your mixes. So that being said, I want to kind of jump right in and show you how we use both of our machines in order to get the ideal CT numbers with our equipment. So the first piece of equipment that I'm going to go through is the Smart Jig, which as you'll see right here, I've got it in one of the Pine 850 presses. It's a modified 150 millimeter Lotman head. And what it does is basically integrates all the parameters that you would need to get ideal CT into this piece. It has a built-in load cell and an Lvdt for your displacement measurements. So in using this machine, it will come with, obviously, the control boxes on the back. It will come with a charger. You've got some spacer screws in order to make sure it's aligned properly with the Pine machine. If you have other older style machines, you give Anthony a call, give myself a call, and we'll work through the setup. But it's very simple either way. And then there's also some lubrication. We have some Magnalube, which we send out with each one in order to make sure that you're not getting any resistance from the jig itself. So we recommend this gets done about every 4 to 5 tests. And as you'll see on the software, once you connect the tablet to the Smart Jig, before you run each test, it'll give you a flash you a reminder up, so you won't forget about it. So that being said, what we're going to do first, what you need to do with your Smart Jig is obviously make sure it would be charged up when you receive it, and turn it on. There's a small switch on the back. There's three buttons on the back, which I don't know how well you can see it, but one is for the unit is on. There's a low battery indicator, and then also a Bluetooth connectivity light, which will let you know that your jig is connected to the tablet. When you get your tablet, same thing. They all come with a Samsung tablet. And once you fire it up, the tablets all come preloaded with the software, the data collection software. And it's as simple as turning it on and connecting it to the jig. So at this point, I have my jig turned on, and when you open up the software, you simply hit connect, and it'll automatically connect to it, and it'll switch to a different screen. Now, we've made the setup of the software very simple. So there's no additional parameters you need to fit in. When Ideal first came out, there was some variables that would change a little bit with the specification. But as of now, the specification is pretty solid. So we've taken all those pieces out, and pretty much it's ready and set up to go once you get your equipment. So the home screen of the tablet software allows you to put a project ID, sample ID, technician, put in your voids, your max specific gravity and asphalt content, basically to label your sample that you're running. So you can do that all up front before you run your tests. So at this point, if I look back on my Smart Jig, the Bluetooth button is illuminated, the light is illuminated. Oh, and also you'll get one of these nice little holders with the Smart Jig purchases you can put up here to make sure that you're running the test, so you can have your hands free to catch the sample or maneuver the Pine machine or your other machine as necessary. So we've got the initial setup. We've got our jig. As I said before, the jig will come with 2 spacer screws. And for those of you familiar with the Pine press, there's 2 holes in the back of the bottom platen here that you would screw in. And what this will do is make sure that the jig is centered when you have it inside the machine. On the back of the Smart Jig, there'll be 2, just like with your typical Lotman heads, there'll be 2 spaces that it will slide directly into. so that you'll make sure that it's centered directly up under your old load cell from the Pine machine. Also, the machine will come with an LVDT. It's a 2-inch LVDT that needs to be plugged in to the electronics of the smart jig before you get started. And the LVDT will measure your displacement throughout the test, which is a critical parameter in configuring your ideal CT numbers. Now, as you can see on this smart jig, we've got a little bit of an older variation. The LVDT is actually mounted in the back of the smart jig. Any new ones that you would get out, or any ones that we would deliver from here on out, will have the LVDT mounted on the side, and that will align properly with the screws that we just put into the back of the Pine. For this demonstration, unfortunately, we don't have any new ones here right now. We are moving them through production fairly quickly, and caught us kind of right in the middle. So I've got one that's mounted on the back. So I'm just going to make a slight adjustment, but it's the same parameters and the same, pretty much the same setup. So I've got my LVDT, and I'm just going to plug it in to the back of the smart jig. And then also with the smart jig, you're going to get this contact magnet. And what this is it affixes to the crosshead of the Pine or any other of the load frames, and make sure that your LVDT makes contact with this before the load cell does, which will give you your displacement readings. So anything that needs to be calibrated on the smart jig is the load cell, which is located under the bottom plate, and then the LVDT, which is able to come off the jig as well. And that 3 strong magnets to make sure there's no play, no wiggle room once you affix it to the crosshead. One important note, and we're able to work and do these meetings residually as more and more contractors in Colorado end up with this equipment. If you want to set up a personalized Zoom or WebEx meeting with us, we're available to do that as well. So what we want to do is make sure that the magnet, you can unscrew it and it can come down for a ways, but we want to make sure it's all the way up in this position. And then what we also want to do is make sure that it's going to make contact before the old load cell makes contact with the crosshead here. And the reason, but the software won't start reading that displacement until the load is recognized and engaged.
So you were just saying the reason is, and then you got a little glitchy. What's the reason for that?
For the
that it contacts the thing you were just.
Oh, you want to make sure that, yeah, the displacement is going to start reading first. And what you want to do is make sure that that doesn't start after the fact. Obviously, the whole area under the curve is important to your ideal CT number. So if your displacement starts after the load starts reading, then you're going to get an erroneous curve and it'll give you a bad number. So for this one, we have that long 2-inch LVDT, which has plenty of stroke length. So you just want to make sure that that makes contact with the magnet before the load is engaged, before basically once the machine starts moving up, before this cross beam hits the load cell. So you always want to make sure that the LVDT, the displacement starts reading first. And then on the finalized graph, you'll see the LVDT won't actually put out data until the load cell is engaged. So everything starts at the same time, which gives you your proper ideal CT number.
Okay, yeah, you kind of just cut out just a little bit while you're explaining that. I just wanted to make sure I didn't miss anything.
Okay, but did that explanation, did the second time go all the way through?
Yep, got it. Thanks.
Okay, perfect.
That was actually on me. I went into a landline, so it cut from Wi-Fi to LAN. Sorry about that.
No problem. Excuse me. Okay, so now we've got our jig is connected to the tablet. We put in all of our parameters. And at that point on the tablet, I know it's kind of tough with the lights in here, but there's an accept button and I would hit accept. And at this point, there's a button here that says start the test. So you're ready to go. And this will give you plenty of time between when you hit that button and when you start the test to go ahead and start it. And again, these will come with this. If you have something else in your lab that you're using, I would highly recommend having this, especially if you're going to run it individually, because with moving the machine and having to hold down certain buttons, it'll be necessary for you to see the graph. You'll get a real-time plot of the test when you're running the smart jig. which is beneficial, and it'll also tell you when the test is completed and you have enough data to run your ideal number. So that being said, my Pine machine is on, and I want to make sure I'm down. I'm going to hit the yellow button to make sure it's all the way down into the home position, which I've done. At this point, I'm going to go ahead and put a sample in to the smart jig. So like I said, if you've got the newer version of the smart jig, this will be centered. You'll have your magnet ready, your LVDT right up under your magnet. And I've got one of the older styles, so I've got to turn it just a little bit as the LVDT is mounted in the back. So if I look now, I can actually make, this is, the machine is in the home position. So, and there is more space in between the load cell and the older load cell, the Pine load cell, which again is not collecting any data, and the top platen of the jig. Then there is the LVDT with the magnet. Now at this point, if I want to, I can unscrew my magnet and kind of up and down a little bit. I know it's probably hard to see because we're zoomed out, but you can tuck it in a little bit just to make sure that your LVDT is going to make contact before the load cell does. So at this point, I'm all set up. My tablet is in the start test position, and it's just telling me to press start the test. LVDT is lined up correctly. I've got my Bluetooth connectivity button blinking. Now for the Pine press, it is programmed just to run a certain amount of length and stop. When you're looking at doing your TSR test, obviously all you're looking for is that peak load number out of the test. One of the important parameters of the ideal CT is that it gives the complete area under the curve, and that the test stops when the pressure reaches 0.1 kilonewtons. So, and what it's looking for is that peak load, and then it's looking for the displacement from the peak load at 85, 75, and 65% of that load. So those are very important parameters. For this reason, we need to make sure that we keep the press running longer than it's originally programmed. So for those of you that are familiar with it, the override limit switch is on the bottom, and we are going to utilize this for the ideal CT test. Now, it's important for safety reasons that when you press the limit switch, you press and release the up button. We can't hold both of those down at the same time, or it'll cause mechanical damage to the machine. So if you guys have any questions when you first get this, if we end up setting up another one of these, this will be a key safety piece of it. And there's also safety pieces with the smart loader that we're going to go through as well. So at this point, I'm looking at my tablet's ready, my setup is ready, everything is complete. And what I'm going to do is press and hold this limit switch, and then I'm going to press and release the up button. I forgot to hit start test on the tablet. So again, I got a little bit of clearance, so I'm good. So I'm going to hit start test. At that point, it's going to tell me to lubricate the jig. I don't know if you can see that, but I'm going to hit that limit switch and go up. And I can see right now it's starting to graph the plot. I'm going to use my other hand here just to make sure that it doesn't fall forward on me. And as the plot goes down, saving data, test is met. Test is complete on the jig. At that point, I'm going to hold my sample, go back down from, I may need to use the limit switch to go back down as well. I'm going to take this back down. To its own position. Good grief. All right. And at that point, my test is complete. It says it on the tablet. I'm going to hit details. And at that point, you've got a detailed outline of all the parameters, including everything that is needed for the ideal CT.
Hey, Brian.
If I go back,
Brian.
go ahead.
Yeah, that all we're seeing is white. We can't
glare.
see anything. Yeah, you can't see
Okay.
anything on that. So
and
if Anthony has anything that he could share off of another
I have it
screen.
pulled up on mine if you want to.
We're going to turn this off real quick.
Yeah,
And it
I
won't?
can.
Does that help at all? Can you
No.
see it? No. Okay. All right. Very well.
So I'll just share my screen really quick here.
So, but at that point, what I'm looking at is an ideal CT index of 137.5, all my IDT strength, my peak displacement, peak stability, and then the post-peak displacement that we talked about at 85, 75, and 65. So if you're looking, you want to do these manually, you want to show, you know, kind of show your work. If I can go back to my fourth graders math class, and you want to make sure that all these parameters are there, that is exactly what you'll see. You can also save this to PDF, and then pretty much at that point, you're ready to start another test. So all of these will be saved in the root menu of your tablet, and you can go back and it will be saved by the date, the time, and the project number that you put into the sample number. So those all can be called upon.
Can you see my screen?
Yeah, for clarification, Anthony, Brian was talking about the graph, and I'm assuming when you scroll down to that multicolored line graph,
Yep,
that's what you see.
Yeah, you can batch your files, or you can do individual tests. This is a batch file of multiple tests.
And then that other what you had at the top, that's also data that shows up on the tablet.
Yep, this also shows up on the tablet. This is going to be your actual the data that's output before the graph.
And it's obviously all,
and then it'll all come together.
It's all exportable into.
Yep, all exportable.
Okay. Thank you.
Yeah, the unit comes with a software that you can download on your computer as well, and all the tests that you take on the tablet are then extracted and put onto your computer and put into the analysis software, and this is what that produces for you. So it shows the initial graph on the tablet, and then once you do the analysis on the back end, you can then put the batch files and do this all together like this.
Thank you.
But you'll also get this data on the tablet as well.
So at that point, once you do those, or if you're doing a group of tests at the same time, you'd be ready to start the new test. What I would encourage you every time that you look at the setup, then make sure it's done correctly. Obviously, like I said before, your jig will be done this way, and the orientation should come right back to the same as I just showed you before the test. It's in the same position. Once you hit that yellow button, get it back down to where it needs to be. It will return to the same position. If I was going to load up, I have a couple of TSR samples here too, obviously the same diameter. So there's going to be no requirements as far as, you know, shifting the jig around. You just need to make sure your sample is centered. And then we'll go ahead. Well, I'm just going to run one more since we're here. And as you saw, the machine itself, or once it breaks, it's good to have a free hand there to make sure that it doesn't fall down, or you obviously don't hurt yourself. But if you're used to running this machine and running the TSR, then you kind of know that already. So I'm sure, like I said, you maybe can't see it, but we're back at the start test button. And so what I'm going to do is make sure that my unit's on and I'm ready to go. So I'm going to hit start test one more time. It's going to ask me for all my parameters of the test. I'm just going to hit accept. Telling me to lubricate the jig, limit switch, press and hold, and press the up button. My Lvdt is making contact well before the load head is. And as you'll see, and it's starting to grab those numbers right away. And then it's going to let me know. All right, saving data, test complete. You may have to run this in teams of 2, depending on how big your samples are. Not really, but. And at that point, I'm done. So I'm gonna hit the limit switch again. Gonna move it back down. It's home position. And again, I get my test is complete. Can look at the details, can go back, can save it to PDF, whatever we need to do there. So as far as your Pine setup or your older load frame setup, that is how the smart jig is run. And again, I'd strongly urge you, when you move forward and get a smart jig, give us a call. We can go through this initial setup. I know today's a lot of training and just a lot of listening, but the hands-on piece of it, we're more than happy to do this for any of you that actually that pick up a smart jig.
Before you move on to the load frame, have
Yes.
you experienced you know, there's a lot of labs here in Colorado that are running United presses. Have you experienced the load jig running in a United press, and does it operate very similarly to that pine press?
Well, it's going to run similar. It's going to run similar no matter which press you use. It's just a matter of how the familiarity with your technicians. And then one of the biggest pieces of it is making sure that the magnet on top lines up properly with your jig. So, but if you have those, if there's anybody that has a smart jig, has a United press, I have not worked with one specifically. Anthony's more of the Colorado representative. So Anthony, can you speak on that at all?
Yeah, it's going to be very straightforward. You can use it in the same way. The one thing that we did have to change was some of the frames, the United frames. The older magnet style didn't work, so we had to come up with the newer style. But now the magnetic will allow for the range, and the height is slightly different on the United frame. So, but the contact is able to be made because of the adjuster that we have on the magnet now. So the Lvdt can make contact. It should be no problem with the United frame.
So Anthony?
Yes.
Anthony, but it uses your software even in the United presses. Okay.
Yes,
Right, yeah.
absolutely.
It uses our software. And again, the load cell is built into the smart jig and the Lvdt is built in. So it's not using any of the hardware or the software. All that information is correct. And it also will give on the readout, I don't know if Anthony can pull that up, the average speed for the test as well too. So you can see how your machine is doing. I think it's 50 millimeters a minute plus or 2 inches a minute, 50 millimeters plus or minus 2 at this point. And I think that there's some talk, I know with COVID, everything happened about them expanding that out to 5. So what they're finding is the speed isn't as much of a variable on the test, but obviously it's going to make a little bits of differences as you get farther away from that post peak for your 85, 75, 65 displacement number. So,
and lastly, the tablet comes with the jig.
Yes.
And then it is exportable PDF, so it will interface with our storage on our existing machines, I guess, or whatever.
That is correct. You will need to, if you have a lot of companies with IT nowadays are very wary of obviously hooking other devices up to it, but you may have to go through your IT department just to make sure you have the ability to connect this and email from it. Also with the tablet, the updates are available via Google Play Store. So if you've got a phone right now that automatically updates, this would need to be set up in the same way. We've had some customers that have made like a dummy Gmail account or some that have used their own Gmail account. And then as new updates become available, we will either let you know, or if you have that set to be done automatically, it will automatically update like when you're sleeping and your other apps update on your phone.
Okay, thank you much.
Mm-hmm. So at this point, we'll move on to the smart loader. Again, the smart loader is a little bit more diverse. It's going to bring a little bit more ability to do some more testing, including stability and flow. If you're into that, we have a Texas right now is into a shear bond. They're testing their interlayer shear bond strength with a different type of jig, but the setup still remains the same for the tests. So the smart loader itself will use a regular older style Lotman head, which most of you have. You can use the smart jig and the smart loader. I don't know why you'd want to, but that it would work in there. It is a Lotman style head. Again, for this one, we use the load cell is on the machine, not built in like the smart jig is, and we have an Lvdt that comes with the machine as well that needs to be set up. Once you go into the machine, you go into, and there's you won't be able to see it here, but there's it says standard name. And then for this machine, if I click on standard name, it's got iFit, which is the Illinois Flexibility SCB test, Ideal CT, TSR, shear interface test, and Marshall test. So there's a few different tests that are programmed in here. Good thing about having a smart loader is that you can program it for anything you'd like to do. If you want to do some testing, some trial and error with your machine, it's got 10 programmable basically programs. So if a new test comes out, they want to run it at a little bit different speed. You want to check your ideal CT numbers at different speeds. You can set up the machine pretty much however you'd like it. We'd recommend you call and us walk you through it. But for those of you that get the smart loaders, it will come completely ready to go with your with your ideal CT test pre-programmed. So that being said, the initial setup of the smart loader, it comes calibrated, it comes ready to go out of the box once you receive it. The only thing will be that the Lvdt will not be mounted in the holder. This holder will be mounted on it. The load cell will be mounted on it, and it will be calibrated. So we try to make it as easy as possible for everybody when they get this, so they can get up and start running right away. There is one little piece with the smart loader. It's a small piece of metal. It fits in the base platen of the smart loader, and there's certain jigs that have centering kind of alleys on them where you can make sure it's completely centered. For most of us in the allotment heads don't have it, so I just recommend keeping this piece in the junk drawer in the lab or somewhere you know you're going to be able to find it. If you get into, I'm going to hit ideal CT here and get back out. Okay, so I'm set up to run ideal CT, and there's a few different buttons on the screen that I just want to talk about. There's a test position, which is basically going to raise your bottom platen into the test position, and a home position, which is kind of like the resting position on the Pine. So home position is where you're going to leave the machine when you're not using it, when you bring it down, when you unload and load samples in it. And then test position is what you're going to use. You want to make sure that everything is lined up where it needs to be, so you can hit start once you get it into test position. So right now the machine's in load position or test or home position, and this would be kind of what it would look like when I took it out of the box. The one thing I will need to set up is my Lvdt, which will come plugged in, and basically the Lvdt holder will come as part of the unit as well. So there's some simple screws on the back that you can tighten. And right now, what I want to do is just tighten it loosely so that when I put my allotment head in there and bring it up to test position, that I'm in the right spot in order to run the test. But the great thing about the smart loader is that once you set your height for your Lvdt, you're pretty much ready to go. You can bring it down to the home position, bring it up to the test position, and pretty much hit start after that. It's going to be ready to go. We tried to make that easy. So what I want to do right now is I'm going to go ahead and bring it to the test position. One recommendation as far as safety, make sure if you're bringing it up to test position, you don't have anything in it to start. The reason being is it's going to give you a warning once I go to test position that it's going to move to that position regardless. The load controls, the displacement controls are not enabled at that time. So if you put your head in there and hit move to test position and hit and allow it to go, it's going to move there regardless of how much the load cell is being depressed. So again, it's a small safety thing, but as a manufacturer, that's what we would recommend. So I'm going to bring it up to test position right now. And as you can probably hear it, it's moving. And again, it's moving without any load control. So if I had a sample in here or whatnot at this point, it would continue to break it until you got it to test position. So now the machine is in test position. So this is where the machine's going to rise up to every time you're going to run an ideal CT test, a TSR test, a Marshall test, et cetera, whatever you're using the machine for. So what I want to do here, same thing with the smart jig. I want to make sure that Lvdt is just above my post. So I'm just going to lower that down and tighten it. And then I'm also going to take my sample, raise it up, and put it there too. So right now you've got about, I'd say about a nickel's worth of clearance there on the Lvdt or on the load cell, and your Lvdt is nice and tight, and it's right on sitting on that post as well. So your Lvdt, once you start the test, is going to make contact first, and then your load cell, which is what we want. Now the good thing about the difference between the smart loader and your Pine press or your smart jig is that this is an automated test. So once it reaches that 0.1 kilonewtons or the stop criteria for the test, the machine will stop itself. It's not going to keep going and things will fall off. Plus, you don't have to hold any buttons down, so you're not holding the sample or worry about it falling. You can just put your samples or put your hands there. So all of the data input for the test parameters on the smart loader is done after the fact in the software. So what you'll see afterwards, I think Anthony, you have that You have it, the smart loader software? Or we can send that to Tom.
Yeah, I can send
Okay.
it all over.
Basically what it is you have a way to label your sample ID on this test in the machine. After that, you're going to want to make sure that you take the USB drive out of there, and you take it to your computer to download the data and to get your graphs and your printable, viewable PDFs. So that was one thing. So all your data is stored. The machine itself does not currently have internal storage. Make sure that your USB is always plugged in. And that's something I like to do right at the start. In fact, we have, I don't know if you can see it up here, our technicians and our engineers having their USB mounted up here with a rubber band, just so they don't lose it. So right now it says test 9. I'm going to get rid of a test 9. I'm going to go with Kappa. So that's how I'm going to know once I get this data out of the machine and off the thumb drive, it's going to have Kappa, and then it'll have the date and time that the test was run. So if you're running 10 tests sequentially, you can, once it gets to your software on your PC, you'll be able to know exactly which ones you ran. Again, there's no internal data storage on the machine. So it's important to make sure that we save the data to the USB.
And I'm just going to share my screen really quick, just to show you a quick walk through. Let's see here. So this would be what you would see when you would open up the software on your computer. And basically you would come to this section right here. Can everybody see, can you see my screen, Tom? All right.
Yeah, we can see it, Anthony.
All right, perfect. So basically you would come to this screen, you would then select the file from your USB, upload it, put in your, you can put in your test parameters here, and then you'll just upload it and it'll plot it all for you, save changes, and it'll pull it all up. And then you'll get basically the exact same readout that I showed you earlier with all those parameters.
And the good thing about the smart loader, you can do up to 10 tests at a time. So you can import those and you can graph them. So if you've got data from, let's say, a DOT project, or the DOT ran this data, if you're using the smart loaders, or if you have another lab that's using a smart loader, you can put those all together and put them on the same graph to make sure you're getting similar data as you can with the output from the smart jig. So at this point, again, I'm ready to run the test. I have my ideal CT test. I'm in the test position. My Lvdt is going to make contact first, and then my load cell is going to make contact after that. There's a blue round play button here. So I'm just going to go ahead and hit the button. Oh, Thomas. Hold on one second. And we were doing a demo for another company the other day. I apologize. Let me just go ahead and move. I have to reassign. The load profile. Oh, there it is. Sorry. Okay, now we're good to go. Sorry about that. And I'm gonna hit start. Now, what the machine's gonna do, it's gonna move at a very slow rate until it feels that initial load, and then it's gonna run at the 2 inches a minute. So, I mean, obviously you can't see it or hear it right now. The machine itself, the time is running. I see my Lvdt has made contact, and now I'm looking at the load cell to make contact. As you get more involved with your smart loader and as you use it more, you can play with that test position. You can even move this cross beam a little bit up and down, so there's a little bit less play or a little bit less time from when you hit start until the test starts itself. But that is all about, getting comfortable and feeling comfortable with the machine. And just like the smart jig, if you have any questions or get the machine and want to go through one of these demonstrations, we're more than happy to do it. All right, so it got the initial load. Now it's doing the test itself. And again, this one will stop when it reaches the stop criterion for the test, which is 0.1 kilonewtons. Hands free. All right, so at that point it stopped. Now it's coming down. So I can go ahead and manually get rid of this one. and it'll give you, it says end test stop maximum load and then maximum deformation. After you're done, you can see the graph on the screen itself, but then it'll ask you to save the data to the USB drive, which we have plugged in. So I'm going to go ahead and hit that graph. As I don't know if you can see it, but it's a nice graph looking exactly like I would want my ideal CT graph to look like. The post peak slope is not too steep, and it definitely ends at the 0.1 kilonewton. So looking good. There is a picture of a disk on here, which means you want to save it. So I'm going to hit that. I'm going to hit the disk, and it's saving test results. Please wait. So it's saving the test. At this point, I'm pretty much ready. It tells you you're complete, and I can go ahead and run another test if I'm so inclined. So we're going to do that just to show you how kind of easy it is. So what it does after it gets done running the test, it will return to test position. And again, if you have all your parameters set up, you can pretty much go ahead and start another test. So if I load that up in there, my Lvdt, my load cell, everything is lined up properly. So I would say when you're not using your machine, you can go ahead and move it down into home position. But if you're using and you're going to run multiple tests at a time, go ahead and you can leave it in test position. So if I exit out of there, basically it takes me back to my home screen. I can rename this sample ID and go with another sample. And I guess we're running on time, so I won't test another sample. But any questions on either unit at this point?
I've got a couple. I don't know if anybody else does, but I've got a couple. So you talk about there's no internal storage on the load frame.
Right.
I've typed him some questions to Anthony, but he's just being not answering. He's being.
He's got his head down on his desk.
So can you? So if I I run the first sample and I don't have a USB drive inserted, I go, oh my God! Can I then plug one in after the fact?
Yes.
Before I run the second test.
It'll tell you if you don't have one plugged in and you hit save, it says does not recognize USB. So there's some sort of
okay. That was going to be my next suggestion, that when you're running through the setups, that your software guys could put no USB drive inserted to remind somebody to put it in. But you said it comes up after the fact.
Yeah, there will be an error that'll say
in saving the data.
Yeah, it'll give you an error and say you need to insert your USB, and then you can go grab it and throw it in, and then it'll continue saving.
Okay, those were my couple of questions, because I could see that as a somebody goes, oh my God, and then you lose 3 tests worth of data because they didn't have a
right.
drive.
Yeah, but it'll ask you after each test. It'll have that little disk there to save it. So
do you want to save the data?
Right.
Okay.
Sorry, you're quicker than me, Tom. Way
Yeah.
quicker than me.
And again, for anybody that's on the call, if there's any questions at any time, Anthony's there. They can come through Kappa. We'd be more than happy to answer them. If anybody, or when you receive your equipment, we'd be happy to run through this individually. So, it's easy for me to stand up here and do it, but until you get your hands on it, that's when we absolutely be happy to take the time to do that.
Quick question that I've been wondering about is in the ASTM procedure, it talks about the target temperature that you're cracking the specimens. And it looks like there's 2 different options. There's a calculation. They're using your PG temperatures, or they just state 25 degrees C. Are you guys seeing that there's either or being performed nationally, or what do you
usually usually the 25 degrees C is anybody that we've been working with haven't gotten really in detail with some of the folks and how they're using it, but the non-research folks, the ones that are using it for their crack testing as part of their balance mix design, that seems to be the parameter that's prevalent.
25 C. Okay, that would make more sense, because then you could just have one water bath. Or is that actually a water bath, or what an air bath? You put those in?
I just did some comparison testing with New York DOT, and they were using both. So the contractor was using an air, and they were using a regular water bath. Obviously, we recommend that if you're going to use one throughout several labs, you use either all water baths or all air.
Okay.
And for most of the trainings that we've done, I haven't seen people using the water baths as well. It's mostly air, but I guess that's up to the contractor and the DOT.
What does the ASTM state?
It says environmental chamber or water bath. It's 9.1 of the procedure. So it's I guess either or.
Sounds to me like they're saying that the critical temperature is 25 and just get it there.
25, and then it talks about this PGIT, which is a calculation that you use based on the PG binder you're using. So
Yeah, in my comparisons, it's been mainly about the temp rather than the PG.
yeah, that would make sense.
Mike Stanford, do you foresee any Colorado procedure coming to clarify points like that?
He's not unmuting. Mike, you there?
Okay, sorry. Haven't really given it much thought at this point, but yeah, we'll probably need to come up with some kind of CPL down the road, I imagine.
Hey, I do have a question. Can you hear me?
Yes.
So my question is more about specimen preparation. So I don't know if this is the best time to ask it or not, but how are we targeting like the weight that we're aiming for our puck to put in the press? It gives me dimensions in the procedure, what dimensions I want my puck to be. How exactly are we getting there? Does that make sense?
Well, that would
Yes.
probably be controlled by getting what you need to get your air voids.
So are we using a calculation like we do with Lotmans then? To like target a height?
Yes.
Yeah.
Yes, Alex, yes, that's correct. It will be from what we know from, the researchers is you're compacting them just like you would compact a Lotman sample.
Okay.
And then average air voids and averaging out air voids to try and get your gambit.
Okay.
We do have just, oh, go ahead. I'm sorry.
Is that transferable? When I make my Lotmans, they're 4-inch. This is 6-inch. Are those numbers?
That's where the next comment was going to come. That
Okay.
and in our balanced mixed design work group, one of the things that came up with that was that Dr. Randy West from Ncat made the statement to all of us in our last work group meeting. There is a way you can back calculate to a 100 millimeter sample. However, it is not a ideal situation. For those who were on the call, Mike, you were on that, Stanford, you were on that call, but he said it's not an ideal situation. He suggested that these samples be run on 150 millimeter, that we transfer over and run these on 150 millimeter. With that said, knowing that Colorado right now is a 100 millimeter state because of the beam stabilometer, this test will basically eliminate the need for the beam stabilometer. And in our last meeting, and I see a couple of our RMEs are on the call. I'm going to call you guys out. Both Jody Pieper from Region 2 and Cole Golden from Region 3 were on the call, and we had this discussion and said, would there be a lot of pushback from the state DOT to switch to 150 millimeter, so that anything that we're doing in Colorado could be easily compared without going through the hieroglyphics to anybody else that's running these tests in other states or anywhere else. And Cole, I'm going to ask you to unmute, but that question was asked, and the response that we got at the time was they didn't see a problem. So I would throw that back out to our DOT partners and for comment on that.
Yeah, Tom, I think like at that last meeting, if we're going to be able to get the data we need some other way, we aren't tied to 4-inch samples just to guide them. But Mike is probably more of the expert on that.
Stanford?
Right. And for our ideal CT testing that we're starting to do, we're doing it in the Euro lab where we compact the 6-inch pucks for the for the smart tracker anyhow. So we're just producing more 6-inch over there.
And that was one of the comments, you know, when the part of the balanced mix design is you have to run a wheel tracker. Wheel tracker, you cannot do it on 100 millimeter, no how, no way. So that was part of the comments. If we've got to do balanced mix design, we have to have 150 millimeter samples. Let's just go. Let's jump in the water. Let's not just dangle our toes in the water. Let's jump in the water. Is that fair, Michael?
Well, certainly with the in terms of the ideal CT, yeah.
Todd, you've been running some of these tests. You're doing 6-inch, aren't you?
Unmute. Okay, you can hear me now?
Yeah, go ahead, Todd.
Yeah, we did our tests with the 6-inch, and I believe we used, and Eric, you can jump in. I believe we used the calculation provided at the Ncat course for determining the weight to get to your void content, and seemed to work pretty well.
Okay.
I think for that piece of it, any more questions? And just real quick, I know that Anthony told me that the price of the machines was discussed on chat, which is great. Calibration price, at least for what we do for each one annually, because I know there's been some discussion about how much things cost to calibrate once you get certain equipment, is about what we charge is about $295 for the smart jig and about $400 for the smart loader. So just wanted to get that out there and for topics of discussion.
Any other questions from anybody?
What states are starting to adopt these machines?
A lot. So for me personally, New York, Pennsylvania, New Jersey, I would say are the biggest ones that I've dealt with so far. I know Brian deals a little bit more into the Southeast and up into the Midwest a little bit.
Texas, Ohio, Virginia. Yeah, Virginia is big. We just did a whole thing for them. So it seems to be that the momentum for everybody moving towards balanced mix design is on board with these machines. I know there's a few more that are coming, and obviously, you know, we're got to be at the forefront. But those are the ones that we've been mostly working with on the East Coast for BMD, specifically for this equipment and our Hamburgs.
The last map I saw out of Ncat had, and Michael Stanford, you may have seen the same thing, 22 states that were either fully implemented or partially implemented, and another like 15 that are in the state where, in the condition where Colorado is right now, where we got stuff going, but we haven't done any implementation. So that would put us up to near 35, 36 states. And so we know that, I mean, looking at other things that have been implemented, California implemented Super Pave, 3 years ago, finally. So, you know, it takes a while from some states to get around to it. And I say that kind of with a chuckle in my voice, because it took a long time for California to implement Super Pave, but they're one of the states now that BMD is on the forefront. They're already mostly implemented in California. So, you know, we're in the middle of the mix here for sure in Colorado, and getting things out there that, you know, we need to move forward. There is so much evidence that this mix design method and mix approval method is proving to be far superior to what we've been doing with swagging adjustments to mix designs.
With the states that are already in the lead with using this test, has there been any indication yet of positive impact to the actual mixtures on the road or in place performance? Are they starting to see anything change from a design perspective as well as a performance?
I think with Ideal pretty much came out about 2 years ago. So as far as from the testing in the labs to the laydown, we're still kind of early in the process. A lot of states are doing round robins. Virginia was one that we just got done with. They had their first round of round robin, so we went through all the products again. Most folks in Virginia have either the Smart Jig or the Smart Loader. That, I think where we're at with that is pretty much in that phase of it, where we're waiting to at this point to hear back from actual production and laydown tests.
The early results, Todd, out of Texas, Indiana, some of the other states in the Southeast, they've shown in the first 2 to 3 years, they've shown a much more reduced cracking in those first, cycles, where they were expecting to see cracking within that, same thing that we talk about here, an inch per year. They've got roads that they have no cracking that has reappeared. So their early thoughts are that this is being very successful. The long-term results coming out of Ncat should be published in April, a year from now. So they're doing some stuff on, they did some stuff on the test track down there. So they've got, tons of data doing their 20-year loading stuff. So we should see that soon.
And, and I guess I'd be most interested in the northernmost states that experience a lot more freezing, cold temperature related cracking.
That's Indiana.
I truly believe that as long as these states are addicted to single lift rehabilitation techniques, it is extremely valuable what is achieved with this process to be able to eliminate the cracking and still carry the load. Our feeling in Region 5 is we don't like to lay single lifts. We always do multiple lifts to achieve the same thing. We've had a tremendous reduction in cracking, but that's because we provide a flexible interlayer underneath. To speak to the 150 mold situation, if you are a Troxler-driven lab, the crossover would not be very costly. There's tons of molds that have never been used. Heads are not as expensive. I think the transition wouldn't be too bad. I don't know anything about the Pine labs, whether they come set up or whether there would be a cost to transition to 6-inch or 150 for them. I'm a big supporter of what we're trying to achieve here. I think it has a lot to do with the great improvement in mix designs and mix performance. But again, we've been trying to get there through our old antiquated system.
Thanks for that, Pat. That's good comments.
Anthony, can you talk to what it would take to switch a pine compactor over to 6-inch as far as cost? Or can you even do it?
So as far as without the Smart Jig?
Just
we've been buying pine compactors in the state that are 4-inch, which I know you guys made special for us. Now we're talking about switching over to the 6-inch compactors.
Oh yeah.
What would it take for us to get those compactors that we've purchased switched over to 6-inch?
Yeah, so it would be a fairly easy fix. Most of the ones that I know that I've been involved with the sale of already came with the conversion kit for the 100 millimeter to the 150 millimeter. So a lot of those should already be in place. As far as the ones that do not have the conversion kit, I think that those can be installed in the field. So what we could do is you could get those ordered up from the ones that do, the labs that do have the Pines. You can get them ordered from the Pine. I can get some pricing over for those conversion kits. And then I know our technician, Jeff Miller, could come out and install that as well. Because it's an easy switch back and forth from the 100 millimeter to the 150 millimeter. So
it's a lot easier on the Pine than it is on the blue one.
Much easier. Yes. Much easier. And cost effective as well. The conversion kits aren't an astronomical cost. And they come with, in Colorado thus far, most of them already come with the 150 because of the AMRL inspection. So we already send that out with at least the conversion kit so you can do those samples for the inspection.
I think our biggest cost is going to be in the molds themselves, guys, not the conversion, but the actual molds.
Yeah, because you're looking at about close to $1,800 per mold.
Stop bouncing, Anthony.
I know that nervous energy, and I'm not even nervous.
You're making us all seasick. Anybody else have any questions or comments or concerns about either of these two pieces of equipment that Brian, the tool, has shown us? I will tell you that in the Asphalt Education Center, we do have a smart jig, and anybody that would like to come down and take a look at it, touch it, feel it, smell it, we've got it in our facility, and you're more than welcome to come down and take a look at it. As far as taking it out of the facility, it was given to us so that we would have it as a demonstrator model. So I wouldn't allow anybody to take it out of the facility, but we do have the United Press down there, and we can run it. You can bring down samples, run it through our machine, run it through the jig in our lab if you want to get a feel for it before you test drive it before you buy it, kind of thing. So we're more than happy to arrange for that for anybody that wants to come down.
I'll also add just one more thing, Tom. As things begin to open up a little bit more, I'm going to become more available to be out in Colorado to come in and help anybody with setup, help anyone with the initial testing. So that's going to be really nice moving forward. I don't have an exact time frame yet on when that's going to happen, but it's going to be pretty soon. So
He wants it before the end of ski season.
Copper's calling my name.
So when that happens, Anthony, we'll need to have you come in and help us get ours completely set up. So
perfect. Maybe we can arrange something to where, if we can have more than 6 people, we could bring some other people in and we can really do a nice in-person demo.
Works for me.
All right, I think we're gonna, if it's okay with you, did you want to go over a couple other products?
Yeah,
Tom?
go ahead and switch.
All right, Maurice is going to actually.
No, not Maurice. Maurice big timed us, so Why we got dead air here. For all of you on the call today, thank you for being on. For those of you that didn't hear earlier, the session today is being recorded, and I will put it up on the CAPA's website probably Friday. I have a inspector certification session going tomorrow, so I won't be able to get it done tomorrow or this afternoon probably, but I'll get it up on the site so everybody can see the demo that Brian O'Toole did, and then whatever Maurice is going to come in here and do for us. So
can you give Maurice the ability to share his screen so we can put the presentation up?
Sure. Let me find his name in the list here. Oh, there he is.
Good to see you again, Tom.
Co-host. There you are. Maurice, your co-host. Yeah, Maurice big timed us, so he doesn't.
I know. Anthony took it all over, man. But I miss you guys for sure. All right.
All right, there you go, Maurice. You're up.
So let's go ahead and get started. Thanks again for hosting this time. We really appreciate it. Thanks for everybody watching. What we want to do now is kind of turn the corner here on BMD and talk about some new products from Instrotek that I think are really pertinent to the discussion, especially asphalt construction and kind of where we are. And these are all new products from Instrotek that are coming out. They've been out for probably the last 6 months to a year, but they might be new to you. So we thought we go through these. I know we don't want to run too long, so I'll go pretty quickly through these. And then at the end, if you guys have questions, we can certainly field those. But so let's get ahead and get started. So we're going to talk about 3 different products, and then one product that we have coming out. You guys are actually a few that will know about this product because we haven't released anything besides some social posts kind of teasing the product. But we're going to talk about our non-nuclear asphalt density gauge. We're also going to talk about the Pave Scan, which this is a brand new system for continuous asphalt density, very similar to the non-nuclear gauge, but this is just a system that'll collect a lot more data. And then we're going to talk a little bit about the AutoXtract for extraction, asphalt extractions, and asphalt content measurement. So let's go ahead and get started with the NonNuke. This gauge has been in development with Instrotek for the last 5 years. We've been thinking about bringing out a non-nuclear gauge, and this is strictly for asphalt. I know everybody asks about soils right away when you say non-nuclear. Do you have a soils non-nuclear? Because that's really the golden goose. But for us, really, the technology right now where we stand is nuclear for soils. But for asphalts and asphalt pavements, the non-nuclear technology has come a long way, and we just kind of have come out with our own brand of non-nuclear gauge. We've had it out for probably the last year or two on pavement projects, and have done quite a bit of research with it. Very simple design. If any of you that use our Explorer nuclear gauge, very similar in feel and look of the gauge. You know, these gauges are basically quality control tools. Put it behind the paver, get your rolling patterns down, and check and see what compaction levels you're at, or what densities you're achieving, to make sure you get that compaction level you need for that roadway. So that's basically what this gauge is primarily used for currently. The nice thing about this gauge, no nuclear license. Obviously, everyone wants to get away from the nuclear license when you're talking about owning a gauge. But for this one, for the paving companies out there, this is real nice. Don't need that license. Again, there's no harmful effects or radiation you got to deal with. Hazmat and transportation for this stuff is very easy, and you know, very easy to own this type of gauge. The output of this gauge, what's going to give you is going to give you density, percent compaction in air voids, surface temperature. You can start projects on it, so you can move from one project to the other and have different projects already lined up for the gauge. It'll give you your GPS coordinates, and then date and timestamp for each shot that you take. So every time you go out there, you'll have all this information come to you through the gauge screen as well. Some of the advanced features, something that we like to think that we did a little different or a little bit better than some of the other non-nuclear products that are out there. We have a quick start button right at the very top. You hit it, takes about 5 seconds to take a test, and you get your results. We have temperature sensors on the gauge, also measuring the pavement temperature, letting you know if it's too hot to have the gauge on there, or if the gauge internally gets too hot. That could affect readings. We have moisture presence warning, auto surface roughness warnings, contact error warnings, and then one of the largest measurement areas for nuclear that gives us a little more area to play with, so we know we're measuring a nice large chunk of the asphalt pavement wherever you're at. And then obviously when you start the gauge, it checks all the systems so that you know the gauges, everything's working properly before you go out into the field. The other nice thing that we did was we added a mobile app. I know everybody nowadays with a computer in their pocket wants to know, what can I do with my computer to gather data, and this actually will connect to any Samsung tablet or phone, and the app is downloaded from the Google Store. Here's a couple of screenshots of what you'll get from the app. It has all your tests that you've taken throughout the day or that you've saved. You can actually select these tests and then send them off to a report that you can email directly from the phone or tablet as well. So it makes it real nice to share information and just see what you did during the day right on your phone or the tablet. The unit does not come with a tablet, kind of like Brian explained, our Smart Jig does, but you can buy one, or we can sell you one with the NonNuke as well. Here's just a quick example of the report that comes with the NonNuke. You know, professional looking report with remarks you can add on the tablet. Everything gets transferred to this PDF, and then you just grab the PDF in the email editor and send it to whoever you like. If there's anybody you want to show them what you've been doing or where you are with compaction at the end of the day. So it makes it real simple. The app also allows you to take pictures and attach them to each report as well. So you can send pictures along with the report saying, okay, this is what I saw here, or you know, on shot line 7, I saw this here. So you can get it, whoever's not right there with you can get a really good view of what the pavement was doing and where with the GPS coordinates. And then one thing that we really like about our products and everything we really manufacture and build is our national coverage. Obviously, you know, we've grown quite a bit. I think Tom knew us when we were just here in Raleigh, North Carolina. We've known Tom for a very long time, and We just started here in the Raleigh-Durham area, but now we've grown to about 7 offices all across the country. So our coverage and ability to help maintain, service, help fix errors, technical support has really grown over the years. And that goes for not just the NonNuke, but really any of these products that you're seeing. I'm going to keep going, and then at the end, I'll answer questions on any of these products just so we can get through them, and you guys can ask whatever you like. So the next product that we're going to talk about is really, I think, the next frontier in density testing, and it goes really well with the NonNuke because it is a dielectric type of product that measures the electric of the asphalt pavement, just like the NonNuke, but you can create a curve, calibration curve, and then assign a density to that. And the PaveScan has been on the market for quite a while, but the second version of the unit has come out recently, and Instrotek has partnered up with GSSI. GSSI is a company in New Hampshire that manufactures these systems, and Instrotek is going to be selling the equipment really all over the world. We've signed an agreement with them to really make this product and promote it, sell it, support it. Anything along with this product we will be doing along with GSSI. They've been a great partner, and we've really enjoyed this relationship so far. So why do we need a PaveScan? Why do we need another machine to go out there and measure density? These pictures you see in front of us are brand new roads that initially, when they were laid down, looked good, and they cored them, and they passed all the density tests without issue, where they cored along the roadway. And the issue is that really when you're coring and you're talking about taking cores, or even when you're using a product like the NonNuke or a nuclear gauge, let's say a 4640, you're really looking at possibly taking a handful of measurements along maybe 2,000 tons of asphalt laid down. So that's the current sampling rate. It's about 10 tons for 2,000 tons of asphalt. And this is from Ohio DOT. This is what they do. You guys might do something a little different. But the PaveScan is able to sample 54,000 times in that same amount of asphalt tonnage. So you're really talking about either taking 10 cores, and that equals about the amount of length for 4 football fields, just put in perspective. And that's why we're really thinking this is the next level in density testing on our roadways. It's not just getting 1 or 2 measurements along the road, or even 10 or even 20 or even 100. We're talking about taking thousands of measurements on that roadway and really creating a contour map of what's going on with your asphalt pavement, so you can really know where the issues may lie or where you're doing really well. The PaveScan is a card-based system. Basically, it does provide dielectric measurement. The picture you see there are the 3 antennas that actually provide the signal and the density information or dielectric information to the machine, and then again that gets converted over to density information. It does our full coverage, and it gives you a contour map. And basically what you're doing is you're going to correlate your core results to density, percent compaction, and percent air voids from the machine. How does the machine work? It collects dielectric information off the surface of the asphalt pavement. The dielectric values can, by themselves, just rolling the machine down the road, can give you uniformity or how consistent your asphalt is throughout. And I've talked to a number of DOTs now that are using this, a number of private contractors, and they really say that dielectric is key in knowing how consistent they're being in laying down the pavement and actually constructing the road. So that's been very helpful for them. Then cores can be taken again to calibrate the machine back to density. And that relationship gives you the density numbers, and it's very, very accurate, extremely accurate. So when you're talking about density, you're really talking about with dielectric. When you're talking about dielectric, for example, air has a dielectric of 1, and water has a dielectric of 81. So when you're talking about asphalt, you're looking at a dielectric of about 4 to 7. Right? And whenever the machine gets on the roadway, that's what it's reading, between 4 to 7 dielectric, depending on the mix type and everything. So when you're running the unit down the road, you're looking for a consistent dielectric measurement. And depending on where you're measuring, if your air voids go down or up, that dielectric measurement will actually shift or move up and down as well. So this little graphic here will kind of show you that as you hit those air voids, and there's more air voids in that asphalt, that top asphalt layer, the dielectric measurement and the contour map you see at the top will change and let you know that you've hit a low spot, dielectric low spot, and in turn means that lower density from the other pavement that's around it or that's in front of or behind it. And you would have to get the core information to know exactly what your density is at those points, but you at least know, hey, this section of road or this part of the road has actually dipped in the number and the dielectric value. Therefore, we know that there's been a change in the way the asphalt's been laid down. You can use a system with 3 antennas. They do sell a system with 1 antenna or one sensor, but the 3 is the main one, and it collects information about 2-foot spacing. And what you do is you roll up and down the project with about a 2-foot spacing between each one, and then you do the center of the lane, and then you do your shoulders with one of the sensors as well. And that way you'll get a whole map of your density and what is going on the roadway after the rollers. To convert your dielectric to density, you can either do 3 low density cores, 3 medium density cores, or 3 high and 3 high. You need all 3 of those. 9 are recommended. They are working on a system to do it with gyratory cores, so you can get that information prior to going out there for that mix. So you would need 2 to 3 at 4 to 5%, air voids 2 to 4 at 7 to 9, and 2 to 3 cores at 11 to 14. That would be your high, your low density or higher void cores. So that's 2 ways they're working on getting, you can get to really correlate the dielectric value to your density. And the process right now is using a sensor that you would use a Darylin or a polymer, and it's a 4-step process. You can see it there. Basically, the sensor with 2 pieces of the Darylin, and then 1 with a metal plate, then 1 with the core, then 1 with the metal plate on top of the core. And that's basically the procedure to calibrate, to create your calibration curve for density on the Pave Scan. So you would do this either in the lab before you went out, or you can go out to the field, look for those lower spots or in high spot density spots and core there, and bring that information back to the lab and do the same thing on the Pave Scan. So
Anthony or Maurice,
yeah,
can you calibrate it to lab compacted samples?
Say that again, Tom. You broke up a
Can
little
you
bit.
use a lab compacted sample when you're doing the correlation or calibration?
Yeah, that's what this last.
Yeah, that's what they look like. That's why I asked that.
Yes, sir. Yeah. So this is it. They're actually, this is something that MnDOT is actually researching right now, and we're looking to put out a product. This is the prototype right here, but we're looking out to put out a product. I'll show you here in a second, a couple of slides later, that will be for the lab to measure the dielectric value in the lab. So all you have to do is do the gyratory cores, and then you'll have that information ready to go. And then you'll be seeing density versus dielectric. Because I know most contractors, they want density. That's what they know. That's what they've been using. That's what they want to see. And it's very easy to do that in upcoming in the near future. So yes, the answer to that would be yes. So basically, we're looking at DOTs looking at eliminating cores, or at least drastically reducing the amount of cores that they have to collect. Ohio DOT has been using this technology for quite a while. They say it's even more accurate than taking cores. You're definitely getting a lot more information than taking cores. And MassDOT has suggested that they're going to save about $1 million a year in just coring costs, which, obviously that's a big amount of money for a DOT, and also eliminating a lot of potholes and from the core holes that you leave behind. So that's huge advantages over this system. Tom, here's that puck kit I was telling you. This is the beta version, but this is basically what it's going to look like, and this is how you'll do this in the lab. So you basically will create those 9 cores in the lab with low, medium, and high, and then be able to use what we're calling the puck kit to evaluate the cores in the lab, and then be able to get it. And we're looking at this probably being ready for commercial later this year, is our hope. So it is coming. It isn't something that's way far off. It's something we are working on currently, and will be available with the PaveScan in the near future. Here's some sample data. This is one where you have your 3 sensors. On the very top, you see L, C, and R. That's your left, center, and right sensors. And it looks like one was over the joint. And so there was a low spot on the joint, and you can place it right over the joint when you're walking the cart, and be able to see that there is a low area on the joint, which, a lot of damage or a lot of failures happen on the joint. So to be able to see that is just a huge advantage. So, hey, we're doing well with our joints, or we're not. And this machine will actually show you. And it also has the the bottom part of it shows you that what that sensor was seeing in the dip in the dielectric value right there on the screen. And this happens in real time as well. So as you're walking, you're actually seeing this histogram and the contour map come up as you're walking behind the unit, and you immediately know, okay, I got an issue here. You know, we need to get either calibrate the density to know what the density is, or we come in core here and see what it was doing. But this is another area where they were, you know, moving the unit, and obviously the blue denotes if you look all the way on the right on the top, you see that the blue is below 90 or right at 90% compaction, and you can see there's a whole section that was kind of below the compaction level. And you can take all this data and with a KLM file overlaid on Google Earth. You know, this doesn't really bring too much more to the game, but it does allow you to kind of lay this out and give more of a graphical look of what you're doing on the road, and whether, you know, all your areas were above passing your compaction level. So again, this is really a QC tool. I talked to a company that is actually consulting with contractors with this unit, and they use this right after an intermediate roller. He gets out there, he does a scan of the test strip, figures out how they're doing as far as consistency and continuity of the asphalt pavement, make sure that everything, you know, it's a consistent mat. And then he'll start rolling right behind the intermediate rollers and let them know if they're having issues. And you can see roller pattern issues, pavement issues, segregation issues, whether the paver's stopping or starting too much. You'll see all this with this system. So it's really nice. And the basic goal here is really to make the producers and the asphalt construction companies have a better idea of what they're doing, not just in one spot or 10 spots or 50, but really all along the pavement project. So it really
Quick question.
Yes, sir.
So have you seen this become an effective training tool for paving crews as well?
Yeah, of course. Yeah, because if you're able to know where you're having issues, and by seeing the dielectric, you can actually start seeing whether it's a segregation issue, because you can see that over a period of space, and you can maybe then visually see it, but you can definitely see it with this machine. You can tell them, hey, listen, we're having segregation issues. We need to talk to the plant to see how we can correct. Or if you're seeing the paving stop, you'll see that density change as well. So you can say, you guys are stopping or starting too much. So you can use it that way. Primarily right now, the DOTs are using it more to really see where there might be issues of low density. And a lot of DOTs, before they get to that, they even do it just for how uniform the pavement is. That will let them know that they got a nice uniform mat. And you know, most contractors have no problem achieving density. But once in a while, you'll have areas that you really need to pay attention to. So you can use that as a learning tool as well.
Have you ever gone out and done like a pre-density check on a road before an overlay went in to see if there's I don't know, any reflection of low density in spots that may have are already low?
You can use this for forensics, absolutely, 100%. I haven't done that personally, but the gentleman that works with us at GSSI has done that and looked at, yeah, you can use it on any asphalt pavement layer. Just know that, you know, the uniformity of the asphalt pavement layer we're talking about is about 2 inches. So obviously you're not going to, if it's, you know, if you got something underneath that's 4 inches deep, that's not going to show on the PaveScan. But that very top layer will do. So this is great for, you know, when you got you're laying down a layer of about 2 inches. If you want to roll it over the top of that and find out what might be going on, you definitely can use it in that way. So just to continue, the rugged deployment of the deployment of the cart, modular assembly, it takes about maybe half an hour, 45 minutes to deploy the entire system. GSI has put a lot of engineering into this. So I know it looks like a big system, but really the cart, the sensors all fold up into themselves. It's I might have a picture in the presentation, but the big handle up top comes off, the tablet comes off, and it basically just becomes that bottom unit that you see there in the picture. So deployment is actually fairly easy, and you can get it out there very quick. It can, you know, put in the back of a truck and get it out there on the pavement site easily. It can accommodate up to 3 sensors, and then again, you know, you do have it does work off batteries, lithium-ion batteries. We suggest having a few out there, especially if it's a big project. But you can swap batteries out while you're out there. And there is a green laser on each of the sensors to let you know. That's primarily for, you know, guiding you down the roadway. Make sure you're keeping the distance so you can really not traverse over areas that you've done, but also for the joints. Very important to be able to know exactly where that joint is and put that sensor right over the joint, so you're getting all that density data right over the joint. So it does have that feature, and that's new to the second version of the system. So the competitive advantage of this, especially for contractors that are evaluating their asphalt, you know, it is an on-site evaluation tool for compaction. It offers full coverage, continuous full coverage, which is really important. And then provides where you may want to core and look at where the core issue, where low density spots might be. The other PaveScan benefits is safety. All of us have heard the stories of people, you know, that have had close calls when they're out there coring or on the job site. And coring, you know, you're after the train, you're well behind the paving operation, usually out there, sometimes by yourself with just the cones. And this system really helps to just really gather that data without having to go back and core as you're rolling the asphalt after your finished roller or even intermediate rollers. So safety is a big advantage of having one of these. And for a lot of contractors, they see it as a safety kind of product as well. Reducing or eliminating coring, we're looking at possibly a future with reduced coring or completely eliminating coring. You know, once this systems have been deployed and being used by contractors or DOTs, just because of the amount of data, and as long as that data is can prove that it is the actual density and core from the cores, you'll have a great correlation there, and we have no doubt this equipment will get there. And then obviously the money you're saving, like I said, Massachusetts DOT saved about $1 million. It says they're projected to save $1 million using the Pave Scan from corn operations. And, you know, for contractors, maybe if there's a bonus factor for achieving high density, this system will let them know if they're going to get that bonus much quicker. So that was the Pave Scan. You know, that's kind of one of our highlight products here. The other two I'll go through fairly quickly. Is there any other questions I can answer on Pave Scan?
Yeah, really quick. So GSSI, and I know years ago we used one of their ground penetrating radars specifically for square yard projects that we had to have minimum depths on. So one of the issues was, and as you said, we see those charts in real time. So we'd have to process data for a very long time. Oftentimes it took far longer than it would take for us to be prepared to start the next lift, and it was effectively useless. So that's this real-time aspect of it. Is there any other things when you just download the data and it's straight up what you see in real time?
Is there any other equipment like that, or are you asking for the Pave Scan in particular?
Well, for the Pave Scan specifically, and then I guess the follow-up to that is, do you know if they've also improved their radar technology with data collection as well in the same way?
I know for the Pave Scan, it's in real time. So you're actually gathering data on that Panasonic Toughbook on the screen. I know Rob from GSSI is in the meeting. I don't know, Rob, if you can unmute, if you want to maybe talk a little bit to that point.
Yeah, sure. I just have one quick question. The just out of curiosity, what was the product you were talking about in the past?
Oh, geez, that was probably 10 years ago.
Okay. Was it for, you said it was for, was it for bridges or some utility? Just
we were looking at pavement thickness, and it was the horn attached to the front of the vehicle.
Road scan system. Yeah, road scan system. Yeah, that does take a while to process the data because, you know, the goal for that was to collect data on the road, and our newer stuff now you can travel at highway speeds. I don't know if you have our Cert 30, but and that way you get on and off the road as soon as possible and start processing the data. Yeah, that can take some time. The PaveScan, a couple of things to know about the PaveScan sensors. Number one, years ago, at least 20, 30 years ago, TTI started doing this particular application, density, using horn antennas, and the accuracy was nowhere near what we needed it to be. So through 30 years of studies and things, and then probably the last more than that now, with Minnesota, we really tightened the what we call the margin of error with these sensors on the PaveScan system. So yes, the road scan sensors are improved, but the PaveScan sensors are really margin of error of what we call the 0.08 margin of error, which is pretty incredible to establish that. So number one. Number two, as far as data processing, yes, you get on-site real-time feedback. So that's one thing. And the other thing is that you can, with one press of a button, export all the data from that project, and we put it into a .csv file as well as a KML file, so you can look at it at Google Earth. But the CSV file, you know, a lot of the contractors and DOTs put it in Excel, which I do. And from there, I can create graphs, I can create statistics, I can create all kinds of different things, whatever I want to do, or, you know, import it into a third-party contouring mapping software that, you know, that might be more detailed for reporting purposes and things like that. And then, of course, you know, pay factors as far as percentage of meeting the densities and things. We collect a lot of data. We provide options to say, you know, hey, I only want to use the data every, you know, 2 feet instead of every 1.5 inches that we collect. So, you know, you can certainly produce outputs that are a little more, you know, spread out rather than very detailed. Okay.
Thanks, Rob.
Thank you.
Appreciate the help. So yeah, there you go. Right from the source itself. Yeah, Rob's been very helpful in getting us up to speed on this technology, and both of us are very excited about it. We've seen a lot of DOTs starting to really take right now. There's a pool fund study going on with it. Minnesota DOTs, you know, going to start implementing pilot projects with it this summer. Hawaii DOTs bought 12 of these to start collecting data as well. So we've gotten really good feedback from the DOTs and where this technology is headed. And if you need anything more, please contact Anthony. He's also been part of the team helping us launch this product through Instrotek, and we have a ton of information we can share with you. So if you guys can just hang in there with me just a little bit longer, I promise this won't take too much longer, and then we'll get to that brand new product from Instrotek that I think anybody that works in an asphalt lab will really want to know about. We'll continue with the AutoXtract. So the AutoXtract is again an asphalt extraction system, and for some of you that do auto extractions for any number of reasons, obviously you have something like this. You know, your hood with your centrifuge. You know, it requires a large footprint. You know, you got a lot of handling of the solvent, which can kind of, you know, for your technicians isn't that great. So there's a lot of considerations when you're doing extractions and you have this type of setup. And what we'll come up with or put to market is this new system called the AutoXtract. And basically it's a closed loop system that does asphalt extractions in about an hour. And what you do is right there, that part you see there is the washing drum. You can put up to about 300 grams of asphalt in that drum. It's a mesh drum, so it filters out most of the bitumen with a solvent. It does use different types of solvents. So if there's a solvent you use, let us know. We'll let you know if it can be used in the system. But again, since it's closed loop, once you close that door, everything happens inside. It does have an exhaust for some of the fumes, but it's very minimal when you're running the system. And again, no fume hood required with the system. It's pretty much automatic. You set everything up, press start, and let the system wash the asphalt with the solvent. Here are the different parts of the system. You basically have your washing chamber at the very top that we just looked at. On the very other side is your control system or your interface. In the middle there, you have your high-speed centrifuge that will filter out the rest. You put a filter paper in there and catch all your fines. can weigh that out after as well. And then you have your solvent extraction tanks. This system will distill the solvent again after use. So you recycle some of that solvent, not 100% of it, but you do recycle a good amount. 80 to 90% of that is recycled, and then you'll have distilled solvent to using it in the system. And then at the very top, you have your distillation chamber, and it all works well all together at the same time. And the footprint, it's about as big as an AMPT, if you guys know what that is. Maybe as big as a 6-foot table, maybe a little bit not as long, and about as tall, about 4 or 5 feet tall. So it is much smaller than having the older systems that are currently in labs. Here's just some of the features. I'm not going to read all of these off, but obviously the biggest thing about this is that you're not exposing your technicians to the solvent. It's completely automatic. Everything's integrated into the AutoXtract. You basically set the system up, put your asphalt in there, press start, and let the system do the rest. And at the end, you can extract the solvent and either do your if you're just doing asphalt content, just weigh the material before, weigh the extracted aggregate afterwards, and then you got your AC content. Or you can, if you're going on to a recovery, you can start that process as well. And then some of the benefits, I think we've touched on most of these. That basically just set it and forget it kind of thing. No calibration or offsets required, kind of like your burn-off ovens or furnaces. It's really good for wrap, where you have a lot of items in. You can use it with polymers and additives as well. And again, it doesn't harm the aggregate sample when you recover it back from the washing drum. All right, so that was the AutoXtract. Any quick questions on the AutoXtract? Okay, sounds good. I'll move on to the next one, which is our latest product. And this product is something we've been working on quite a while, and I think every lab that does asphalt has one of these. So I think you'll be very interested to know that we're coming out with a new front panel for the Ncat furnace. Now, you guys are the very first group to know about this. We're actually releasing this in April 6th. That's Tuesday, April 6th. We'll actually have the commercial unit available for sale. But the Ncat is something that, for a very long time has been used in the industry since the 90s. When it was created to determine asphalt content of the asphalt mixture. And since that time, basically, nothing has been done to the Ncat to upgrade it. About 5 years ago, Instrotek came out with a digital USB drive for it, where you could replace the printer and use the USB, get all your data digitally from the Ncat. And we've really stepped it up with this new front panel upgrade. So what we're doing here is we're not selling the entire Ncat furnace. We can sell it with this pre-installed and sell your brand new Ncat ready to go with the upgrade. But this is a replacement for any older furnaces as well. So you have best of both worlds. You can buy it new, or you can get it with this, just get the upgrade and have it installed. And really what this is going to do is really up the game with the Ncats. You have a touchscreen LCD that has all the parameters. You have a free mobile app that'll show you the live test on your phone or on any tablet. You just connect it via Bluetooth. We also have a Windows application, so you can be there at your desk on your computer and see the burn and what's going on with it. Know when it's finished and go get it. You can do your lift tests from your computer. You still get everything digitally or with the printer. And also on the app, you have ability to email the test results. We incorporated larger buttons because when you're working with asphalt gloves and you feel like you have these huge gloves on your hand, it's hard to push those buttons. So the buttons have gone bigger, but everything can be done through the LCD touchscreen as well. So you have either the tactile or the digital to really run the furnace how you like. And we have a ton more features that I could tell you about. But this is more of just a little preview of the equipment. And coming up in April, we'll have the full release with all the features and everything we've built into this. But a lot of back-end features like the surge protection functionality. It has self-check. It has maintenance checks right on the screen, and it'll walk you through everything on the screen. but it still works like the old oven. So for a lot of technicians, like, well, I don't want the new thing. I know how this works. You can still use it that way. It just has a screen that shows you when, you may need to do something to it. So, we know that a lot of people like doing things the way they were doing it. This is just an enhancement of that with everything that we've put into it. And also all brand new electronics in the furnace as well. So this replaces about 90% of the electronics in there to all new electronics with this, which are very simple and will break down a lot less than what's in the current furnaces. So that's our product release for April. And with that, Tom, unless anybody has any questions, thank you so much. I appreciate you hosting us and letting us do all this for you guys. We're here. We pride ourselves in taking care of our customers and everybody that buys our products. So we certainly appreciate it and hope to look forward to seeing you sometime after all this craziness is over.
Thank you, Maurice.
One question.
Go ahead.
Yeah, I do believe we have one question. Rob or Maurice can step in. The question was from Cole Golden. Does the PaveScan measure temperatures to help identify thermal segregation if an issue? If thermal segregation is an issue, sorry.
I'm sure Rob can answer that, but I'll quickly say no. There's other systems out there for that can do thermal, mapping of the asphalt pavement. Rob, I don't believe the PaveScan measures directly the pavement temperature. Is that correct?
That is correct. It does not directly measure pavement temperature, but and actually, is it Ohio? Craig Lansfeld. He had noticed that, of course, he combines a lot of technology and puts them together and to see if segregation and air voids and density and all this and temperature has a lot to do with each other. And yeah, and we all know it does. So the answer is that once you see sometimes the low density, temperature can be a cause of that. But the quick answer and the bottom line answer is no, it does not directly measure temperature.
There was a question about the ASTM number for the crack testing, and for those of you that didn't see it, it's ASTM D8225-19. So that's a 2-year-old spec at this point. It was written probably 3 or 4 years ago, but got approved through ASTM in 2019. So that's out there if anybody wants to look it up. Again, it's ASTM D8225-19. Let me unspotlight you here. Stop. Oh, all right, so we're back to me. I want to thank anybody. Have any other questions or comments or anything else to bring up at this point?
Hey, Tom, just one other thing. If once we are able to travel a little bit, like Anthony said, if anybody wants to see a demo of this unit, Instrotek has purchased a unit, we'd be happy to come out and do something with either a few of you or a number of you. Just let us know if that's something you guys would want to see.
Before all this craziness happened, Rob Sommerfeld and I had been talking about doing that very thing, and then all of a sudden we're locked down tighter than a nuclear gauge. So we didn't. I had to think of something really I could say there. Yeah, I think that would be something that we'll do in the future for sure. Next winter when we have the asphalt conference, we could even maybe set some type of a demo up, during that, hoping that we would have some decent weather or in the space. We are having, so for your information, Anthony, Maurice, and Brian, we're doing what we're calling the I Love Asphalt Appreciation Days, which are April 30th and May 5th. April 30th here in the Denver area, May 5th over in the Grand Junction area, where we're having just basically a trade show kind of thing for a good portion from 10 to 2. People are going to bring out equipment and set up and do things. So if you happen to be in town, Anthony, you might want to swing by, register for that on our conference website and swing by. But
You got
I'm kind of stalling. Wait, we had another message that came in. Okay, that was just Rob. Not hearing any questions, not seeing any more chat come in. Maurice, do you want to talk about the list on that new faceplate for the ignition oven? I asked Anthony and he wouldn't answer. Maurice bailed out. All right.
I think I answered you.
Well, yeah, but you said that they haven't really shared it with you, so I was going to let Maurice talk about it. So,
hey Tom, sorry, my mic was off. Yeah, absolutely. We're right now we're looking at it's going to be between 25 to 3,000. The reason for the range is we're getting the final cost from all the vendors that we have to get to put this thing together. But I think it's going to be on the lower end of that. And then obviously we know a lot of companies have multiple labs that have 8 furnaces. So please ask Anthony about a good discount, especially for you guys. Tell him, drive him hard on the price and make sure he gives you a good price on it. But we will offer, discounting based on multiple units and stuff like that.
And someday maybe we'll be able to do a demo on that on the one that we have in our facility. So we'll see how that works.
You got it, man. Anything you need.
There was a cheap plug, right, Anthony? All right, guys. Again, like I said, this has been recorded. I will get it up on our website. I'll send out, we'll put a link. There will be a link in the Kappa in front of the paver, which will go out here. We're thinking next week. So I'll put a link in there to that. I really appreciate everybody being on. We had a great group of people on here today. Especially want to thank the DOT people for being on. To hear what we're doing and moving forward. We haven't been able to get together and shake hands and pat each other on the back for all the good work that's been going on out there. So these Zoom meetings, I know we've all got Zoom fatigue and we're tired of it. We'd like to get together and be able to talk to each other face to face. So want to thank Anthony, Brian, and Maurice for putting this on. Rob Sommerfeld from GSSI for being on board as well. Everybody else, thank you very much. And not seeing anything else, I'm going to go ahead and close this thing out. Anthony, you have any parting shots?
Yeah, I just want to say thank you for the opportunity. Really, we love working with Colorado. Love what you guys are doing, always at the forefront of technology and letting us be a part of that. You specifically, Tom, always demoing and showing off our products. We really appreciate it. And thanks for everything you guys do. Thanks for everybody being here. I know it's really busy right now. Things are starting to ramp up. So everybody be safe, and we'll see you soon. Thanks so much.
You obviously didn't see the weather report from here over the weekend.
So things are not ramping up yet. They will be ramping up shortly.
Yeah, well, we got 2 foot of snow on Sunday. So yeah, paving's kind of off for a couple of days. I know that some of the guys, well, David Fife and those guys over on the Western Slope, they just got rain, so they're probably ready to pave. But on the Front Range, yeah, not so much.
Gotcha. Well, either way, thank you so much.
All right, guys. Thank you, everybody. We'll talk to you all later.